So there are systems which use what's called mark and compact. What they actually do is they run mark and sweep, but then they go and they move all the live segments to the beginning of memory. So if we look at our picture, then this guy, let's just free up some memory here somewhere. Okay, we're going to free these memory segments. Okay. So what would happen is that this guy that's taken up would move to there, and the other guy who's taken up would move to wherever he finishes, and the last guy who's taken up will move to where he finishes. And when we're finished, we actually have all the memory taken up, and then we have all the free memory after that, and it's continuous. Okay, so we have a mark and compact. Now this means that after finishing the mark and sweep, we add another step of compacting the memory, of moving all the live guys into the empty spots that actually developed in the middle. You know, all these guys who are empty, all these guys are actually empty. And by doing that, we are actually getting a continuous free memory at the end, and we can allocate as much as we want. So that's what's called mark and compact, which is one one enhancement that we can actually add to the algorithm. Another enhancement that we can add to the algorithm is the following. There's been a lot of research done, and it discovered that data that has survived a memory collection, a garbage collection cycle, will probably survive it again. What does that mean? A lot of memory is just allocated. You need it for a second, you use it, you throw it, right? So that kind of memory won't survive a garbage collection cycle. While if you have some memory which is, let's say, more permanent, so if it would survive a memory cycle, it would probably survive the next cycle as well, right? So we actually can go and create what's called generations. We can have a generation 0, generation 1, generation 2, which means that a data that has been that never survived a garbage collection cycle would actually be a generation 0 guy. Now, we go and we do market sweep at a generation 0, great. Now, those that survived, we move them to a generation 1. And if we need, and people survive twice, we'll move to generation 2. Now, what's the idea? The idea is that notice the biggest cost here is the fact that we have to go and search the entire memory for garbage and not garbage. When we already know that we'll probably find the garbage in Gen X, Gen 0, right? That's where we'll find the garbage, right? And anybody who's in generation 2, for example, will probably not be garbage. An assumption based on research. So why search the entire memory? Why don't we go and split the memory into different, should we say, generations? And we'll say, okay, allocate from generation 0. When you run out of space, you run your garbage collection, and anybody who survived, you move to generation 1. And that's some other memory location or some other list, whatever it is, however you want to classify generation 1. Now, the next time you want to run garbage collection, you won't run it on Gen 1, you will run it again on Gen 0. And again, you'll collect all those which are probably just throwaway variables that you just use for a second, right? And this goes on and on. What happens if you don't have enough memory collected from Gen 0? So then you would run garbage collection on Gen 1 and collect all those which became garbage, even though they're already generation 1. Anybody who survived, move into Gen 2. And that way, we don't have to run on the entire memory constantly in order to find those garbaged variables. We run and we look where we expect to find garbage. Why search the entire street for garbage? If you're looking for garbage, look in the garbage bin, right? That would probably be the best place to look for garbage. So it's true that if you run the entire memory, you'll pass by the garbage dump as well, right? But it'd be a lot smarter to look in the garbage dump. So if I know that most garbage will be in Gen 0, so search in Gen 0. Run garbage collection only on Gen 0. If I go and say, okay, but that's not enough, okay, so let's then move on to Gen 1. And if that's not enough, we'll move to Gen 2. So we can actually decide to not run everything all the time, but work with what's known as generational mock and sweep. And if we put the two enhancements together, we get what's known as generational mock and compact. And that's what runs in the JVM. And the same thing true for the CLR. We're running a generational mock and compact, which means we are running a mock and sweep. We are splitting the memory into generations, and we're actually doing compaction in order to get our free continuous memory in one location. And that is generational mock and compact.